Okay, I wanted to share with you guys my 3D printer that I made back in 2015 or 16. I made it out of old paper printers that the model number was, I think, Epson LQ AD1 something. I can't remember. It's a big printer that used to be used for basically in banks or corporate locations to print the customer paper work and stuff. So I first made it back in 2016 in a Delta configuration, and later I upgraded to a Cartesian, as you can see. So the Z-axis, both of them are driven by belts, and this one also driven by a belt, and you can move it, and it uses two individual end stops to home the machine. Basically the end stops are here. The x-axis is everything is like made out of crap basically. All right, the x-axis just bolted and glued with some 3D printed parts that I upgraded. Originally I made them out of some plywood and just drilled some holes and just screwed in the existing threaded holes, both of them. You can see the reminiscence of that that plywood. And the belt from x-axis is also from the printer. The other I bought I think 5 of them and parted one out to use the belt. And I recently upgraded the extruder to a direct drive Bondtech, I think, clone. It's not the original because I can't buy one. So this is the y-axis, which is also using the linear guide and motion system from the printer. And I bought this heated bed, and there's a limit switch there. This is the controller board. It's a Arduino Mega and a RAMS 1.4. I upgraded the drivers to silent TMC drivers. I upgraded the MOSFET for a bigger one. I'm using a beefy relay in conjunction with a snubber network for the heated bed. And this is the power supply that I modified to be a lower noise one. This is a very old HP power supply. It supplies about 12 volt, 30 amps, I think. It used to have 4 small fans. I took them out and made this cardboard exhaust port for to use a single fan to quiet it down. It's running now, but the noise you can hear is not from that. The noise is actually the cooler from the extruder hot end. All right, I use these ribbon cables from the same printer that these parts came out. These have been in use for about, I don't know, maybe more than 20 years in that printer, and then I started using them for about 5 or at least 5 years for this printer, and they hold up very nice. This is the bed. I also use these ribbons. Basically, I solder them in parallel for positive and negative. I also had one for the thermistor. Very low profile, as you can see. The design of the machine is very basic, and in that time I wasn't very knowledgeable in the field of mechatronics and machining and stuff. I just threw it together and it just works. All right. The axes from the Epson printer, just I drilled some holes and threaded and screwed some long M4 bolts, 1, 2, 3, 4, 5, 6, and some on the back, to a piece of MDF, so I can move it and square it with that y-axis, which I didn't do a very good job, so I used skew correction. By the way, this machine currently runs on Clipper. I recently upgraded to Clipper. I'm running the Clipper right now on this BTT Pi 1.2. It runs great, very fast and snappy. All right. Let me just, okay. Before that BTT Pi, I was using a old case and a monitor, and I was running a basic Linux on a PC. Not PC, it's a computer running Linux, technically, all right? The excuse me. The only major modification for these rails were that the stepper motors that came with this linear system was a 5-wire 2-phase. I don't remember, but I couldn't use the common micro stepping drivers for these motors, so I opened them up and rewired the motors. And by the way, this motor is also salvaged. Almost everything is salvaged from the electronics parts. Even these boards are scrap. And it runs great and prints all right. Can't complain for a scrap machine. There are some parts, and also the firmware I was originally running was Marling, and it was running great, but I couldn't figure out the skew correction. I ran Marling for almost 5 years, 6 years, and finally gave up and upgraded. I did a major upgrade on the machine and upgraded the extruder, the stepper drivers, the power supply. I added these braces which connect this frame to the main piece of chassis. I also did this here. All right, this is basically for rigidity, so the axis can't move in this direction very much. It still can move, but it's not very noticeable. So yeah, I'm currently making PET filament and running the filament in this machine, and it prints nicely. I mean, I added this direct drive, the extruder, and now it prints nice. I printed this from the PET. These lines inconsistencies are not the printer's fault. It's my fault basically. I didn't cut the width of the ribbon good enough for this machine. So, any other points? Let me grab the old extruder from the Delta machine, and I'll show it to you. All right, this is the extruder that I made. This is very crude. There used to be hopped gear in this the shaft of the servo motor, which turned the pushed the filament, and there used to be a E3DB5, I think, coming like this. The filament came from top, and the extruder pushed it inside the hot end, and the hopped gear helped grab it. And this is the idler bearing. This is a very small bearing. I don't know if you can see it or not. Yeah, it worked nicely. And I'm 99% of the prints I did on this machine and the older Delta that was very similar to this, except for this axis was perpendicular like this, and there were 3 of these axes, like in a Delta configuration. I'm sure you are familiar with it. 1, 2, and there is a 3. And I made a arm, and there was an end effector in the center, and the extruder was a button setup. Yeah, I hope you enjoyed this video, and until next time, I guess.